and kinetic. Static friction is the friction that resists the initiation of motion. If you place a block on a table and try to very lightly push it into motion, it will first resist that motion because of the frictional force operating in the direction opposite the applied force of your push. You can push harder and it will still remain still, because the frictional force will always precisely oppose the applied force. Static friction will increase until the magnitude of the applied force exceeds the maximum static frictional force the table can exert. Then the force of the push can no longer be cancelled out, and the block will begin to accelerate. This frictional force is proportional to the normal force, so the heavier the object, the greater the normal force, and the greater the frictional force. This is because as the weight of the object increases, the harder it presses down on the surface, which will increase the number of contact points between the object and the surface. The static frictional force will be anywhere from 0 to the maximum possible value, depending on the forces operating on the object, since the static frictional force will be equal to the applied force until the maximum is reached. The magnitude of this maximum can be calculated this way. F max is equal to the coefficient of static friction times the magnitude of the normal force. This coefficient, represented by the Greek letter mu, is unitless and unique to the surface in question, and we have tabulated these coefficients for a variety of common surfaces, like glass, steel, wood, and rubber, and the various combinations thereof. As we said, once the applied force exceeds the maximum static friction, the object will begin to move. Bear in mind that this equation involves scalar quantities, not vectors, and therefore implies nothing about direction. As we said, static friction opposes the initiation of motion, but once an object is in motion, it is now moving against kinetic friction. This is the force that opposes relative sliding motion. Kinetic friction is always lesser than static friction, which you will notice if you try to push any object across a surface, like a heavy box across the floor. It will be more difficult to get the box going than it is to keep it moving once you've started. There are coefficients of kinetic friction as well, and these will be different from the coefficients of static friction for the same materials. These values allow us to calculate the magnitude of the kinetic frictional force acting on a sliding object.